Hello everyone, welcome back to the workshop, and today we're going to be looking at the Elegoo Phecda 20-watt laser combo. This is a kit that they sell in a few different forms. You can get the basic laser, but they also have options where you can get a few things with it. We're looking at their overall kit that includes their roller rotary, honeycomb bed, some extra filters and such. And as we're rolling up towards the holidays this time of year, I know a lot of people are looking for deals and things they're looking at on lasers, and a lot of people have asked myself about this one. So when they offered to send one out for review, I said, why not? Let's take a look at it. They're not sponsoring this. They haven't paid me for anything or that, but they did just send out the machine for an honest review. That's what we're going to do today. So if you're curious about this machine and what it can do, stay tuned. We're going to dig right into it. I said they do have a fairly decent manual that you can follow along with, and it does call out the screw size on each step. Pretty decent diagrams of each step along the way. However, they also include a small micro SD card that on there are videos for the assembly of both the base laser itself as well as the optional air assist that you can add to this. And so I strongly recommend you follow those videos. It's very clear. They show each step. They don't jump over anything in there, so that will guide you through the assembly of this. Doesn't take too long, takes maybe about 20-30 minutes unless you get hung up on something. The only issue I had is one of the belts had come loose in shipping, so I had to kind of back off the steps a little bit, get that reattached, and then I was able to move forward ahead with the build. Other than that, this does have a bit of a unique setup. The gantry here is quite large because they have these protective shields front and back. This front one is magnetic, and so that pops right off so you can get at the laser module. But the whole idea here is that it's trying to funnel the smoke to this end fan here and up out this filter. So that box has a filter in it that has both a particulate filter on one side and then what looks to be like a HEPA style debris filter on the other, and there is a little bit of what sounds like activated charcoal in there. So the idea is that this is going to help filter out your smoke and debris. We're going to see how well that works. Honestly, I have my concerns that it'll help, but just how open this is, and when you're cutting, a lot of that goes down below this before going up there. I don't have high hopes for it, but they do include a number of extra filters in the kit they sent me. This panel does come on and off fairly easily, so we're going to see how that works. This does have an air pump that came with it in the kit that I received at least, and it does have on the end of it, it has like a variable speed control in there, which is really nice. I like to always run air assist with my lasers, even if I'm engraving, because it can actually improve the quality of the engraving, but it most importantly keeps the smoke and the debris away from the cover lens. It keeps it operating at efficiency longer and prevents that cover lens from getting broken. I did take a look at this, and it does have your standard kind of 16mm brass end on the module that kind of accepts your typical cover lenses. So they shouldn't be an issue to replace those as needed, but it's nice to keep them clean and working as long as you can. Now, as you maybe can see, this is on some elevated legs here. Now, the base one, it comes with just one leg, but they do include a couple sets of additional risers. These just screw onto the bottom and bring your laser up higher. I did that because I have the honeycomb sitting on the same surface, and I've elevated that by about 3/4 with some plywood rails just to allow airflow underneath the honeycomb. It's kind of important to keep that air moving and not trapped, which then brings it up a little bit higher than it needs to, or than it can with the module. It is too high. So then I had to add one of those sets of risers. And if you're going to be using the rotary tool, you might need to add another, or you're going to figure out some jig to raise this up or have a base that goes a little bit lower. But nice that they include them off the bat, that you don't need to worry about how am I going to lift it up high enough to be able to work with this. As far as safety features, it does have some flame sensors on both sides of the gantry. That's to hopefully detect if there is any flame ups, that it can kill the laser and kill the motion. And then it does have tilt sensors in it, so that if the laser is running and it moves beyond a certain degree, it should kill the laser as well. And then they include a set of these kind of generic safety glasses that are tinted kind of a split pea green. And these are better than nothing if you don't have anything. My complaint, this has been with every single diode laser I've received in the past year. There's no rating on these. All I can go off of is, yep, they're green and they're gonna block out some of the blue light. I strongly recommend you get a quality pair of laser safety glasses that are rated for your laser. So with these diodes, you're looking at something in the 455 nanometer wavelength, and you want something with an optical density of 4 or greater. So I'll have a link down below where you can pick those up, but if you don't have them, you're definitely gonna want to wear these as well. They of course have these safety panels on here. They're tinted orange, and it looks a lot like the safety glass that I've used on other enclosures, but again, not knowing the source, I can't speak to whether it's rated or not. And just looking at how this is assembled, there's a lot of open area down here that I think the module may stick down, and you're gonna have some light leakage through there. So always wear the goggles that either came with it, or pick yourself up a pair that is properly rated. Now, there are no limit switches on this laser, and so generally you're going to need to move the gantry and move the module over to your starting point, and you're gonna end up working in from current position. That's not a huge problem. It's fairly easy to work that way, and when my first diode lasers, that's how it was. However, I have gotten kind of used to having limit switches and be able to use absolute coordinates. It makes it a little bit easier to set up jigs for repeatable cuts, things like that. But, you know, looking at this as kind of a budget all-in-one laser that, you know, hopefully has some good features, but isn't a huge price point, it's maybe okay to give up a few of those things to keep that price down. As far as focusing, it does have a little lever on the side here that flips down, and then they have 2 set screws or thumb screws that you loosen to adjust this. This will move up and down at that point, and you touch your focus tool off the top of your material, and then you tighten down the set screws. They're not too hard to get at. They are kind of tucked under here. 2 might be redundant. You could possibly get away with just 1 if you can only reach it. But they are under there, and you do want to get at them make sure they're snug down. The whole module is typical. It rides on kind of a sliding dovetail setup, and then those kind of push in on the side to lock it in place. And then the air assist, the hose does come off the side. There is a little bit of a guide that comes in there. I was a little concerned because they have the actual hose coming down and bending around the module, and it may have a tendency to want to kink there and restrict your airflow. So we're going to keep an eye on that, see if that causes any issues. But then we do just have it kind of zip tied along with the rest of the cable, and it coming out the side. So cable management is okay. They do have the cable tied to the bottom of the side rail here, and then it just kind of sticks out to the side of the frame. So I don't think it's going to be a problem in this one, but we'll keep an eye on that. Again, with these diode lasers and their smaller frames, they're kind of limited in what they can do. They could add cable chain to it, which would add cost, but also bulk. So like I say, it's always nice to see them try to make an effort on it. The most important thing is that the cable doesn't want to drag in on your work area and such. So we'll see how that runs, and hopefully it won't be an issue at all. Now, as far as control, this does have a touch screen up on top, and it has various functions that you can get in. You can manually move the gantry to set up your file, and then they also have where you can turn on and off the various safety features, such as the flame detection and the tilt. And then it does have wireless. There is a small app you can use to send some files to this. But along the side here, they do have a spot for a micro SD card. So you can load your files on there. You can adjust your laser to its start point, focus it, and then you could start the job from there. So it can work offline, but they also have your cable, your USB cable here, and this is a GRBL based laser. So you can use laser GRBL, or my preference is Lightburn software. Should detect it just fine as a GRBL laser and be able to send our jobs to that. So that is the tool we are going to be used to be testing this. And I don't anticipate any issues with this whatsoever. So really quickly, wanted to show the rotary attachment that comes with the kit that was sent to me. It is just your standard 2 rollers, and it does have a bit of a recess. It's fairly low profile, but what I do find interesting is they do have this adjustment knob. There's not, you know, like set screws and belts you need to adjust. There's just kind of this lead screw in here, and you can tighten it down to bring them closer together, loosen it up so that it spreads them apart. And while it's doing that, it is keeping the tension on this belt in here. So this just then hooks up with a cable that then should go into the Y1 port of the motherboard on here. And then you would be able to enable rotary and set that up. With that, I am going to jump into doing some of our initial testing with this laser. And what I like to start out with is some 1/8 inch or 3mm Baltic birch plywood. This is a 3-ply plywood that's fairly consistent that I like to use. I've been using it for years with my various lasers, and it is a nice mixture of durability and strength, but also quality in cutting and engraving. So I'm gonna run a test file through this one on the 20-watt Elegoo module with this laser, and we'll see how it performs when it's done. All right, well, my initial test has completed, and hopefully in some of that footage you saw, it did okay when it was engraving as far as capturing the smoke, but it's really hazy in here now. There was a lot of smoke pouring out as it was cutting, and part of the problem with that is as it's cutting through and pushing with that air assist, the smoke and debris is actually going down below, and then it needs to come out underneath the honeycomb and such. So it's just getting out of the way of that, and there's that gap there. It's asking off a lot of that. So I'm gonna see if I can get this whole thing into an enclosure, because otherwise I'm not gonna be able to continue the testing in here, see if we can get that set up, and then we'll continue on seeing what we can do with this laser. All right, well, I had to get this into some sort of enclosure, and I was able to just squeak it into this one I have on hand. So I'll be able to continue testing, but let's take a look at that first test here. So again, this is 3mm Baltic birch plywood. And as you can see, we just squeaked out at 400 millimeters a minute and 100% power, but all the way down here at 100 to 200, we're cutting through at even 50% power. So pretty decent range and a pretty consistent gradient there. So I feel like the material is looking good. And if you take a look at the backside there, you'll kind of see where they were just starting to hit the fibers and not cut through and just fading off. So I feel like this is a pretty good test for this material. Now, I ran with a little bit of air on the engraving and then full air on the cut. And so the rest of the engraving was done at about 7,500 millimeters a minute and about 60% power. And it's there, it's legible. It's maybe just a little light. So I would probably want to increase that. And then our bottom engraving test, this is in Stucky mode. It's a raster going from 0 to 100%. It's decent, but it's maybe a little bit light on the top end. And so I'd probably want to slow that down a little bit. But, and that was around the max speed, 15,000 RPM, 100% power max down to 0% and a DPI of 300. So a decent raster engraving, but if I wanted to dial this in for photos, I think I'd run a few more of those at a few different speeds. So I want to play around with a few more cut tests quick. I want to try some 1/4 inch material and also try more of a standard vector engrave to see if we get some different results there as well. So I'm going to get that set up in here, run it, and we'll take a look at that when it's done. All right, so I actually ended up running it twice because the first time I forgot to actually turn the air up during the cut, and so needed to rerun it. So let's take a look at how that one came out. This is some 1/4 inch birch plywood from Home Depot. They actually sell this in hobby packs that are about 12 inches by 19 inches. And I've found in some of my tests that it cuts pretty well for this type of material. Now it looks like I've got the ones that are gonna drop out, and we're cutting up to 200. But if you look on the back side here, hopefully it'll focus on that. There are just little fibers there. I'm gonna go ahead and push some of those out with just a little X-Acto to see how easily they might come, and give a better idea of its cutting ability. And that's one thing, that's why I like to run multiples of these, is that sometimes you run into little issues like this where they're really cut through, but there's just a little tiny thread that can be just a weird piece of grain that's holding it on. So it's always great to run these material tests, but it's also, you know, important that you know, check your work, run it more than once and see how it does. So after doing that and just kind of pushing out those little fibers, we have a much better looking gradient here, going all the way up to 400 millimeters a minute. Now this is of course comparable to our 3mm Baltic birch, but this has a real lightweight core, if you can see that there. Whereas the Baltic birch is 3 layers of solid hardwood, this has probably more of a poplar or a very lighter density core. So that's where this wood is nice. You can get a thicker wood with it. This machine cut it out fairly well, fairly cleanly. The air assist seems to be doing an okay job on it. I may check to see if that hose is a little bit kinked, because I feel like it could maybe be just a little bit better, because I am seeing just a little bit of overburn on these top sides and such. But for the most part, it's coming out fairly clean. So with the wood products on cutting like this is okay. I want to run in a vector engraving test and see if that comes out any better than our raster one, and then we'll jump into a few other materials. All right, our vector engrave has finished, and here are the results. So definitely a little hot down at the 7,000 millimeters a minute and 100% power, but up at the 12,000, it's pretty decent, and it is kind of dropping off. There's maybe a faint marking at 10, definitely a little bit at the 20%, but you know, that gives you a pretty decent range with this laser as far as getting, you know, quality colorations and engravings on this. So obviously something you want to do with every single material, and you know, depending on the size of the object, whether it's vector and raster, you know, that's why you want to run some of these multiple tests to see how it performs in. All right, just ran one of those aluminum business cards that are very popular. Ran it at 8,500 millimeters a minute, 60% power. Took about 6 minutes. Let's take a look at it. And so here it is straight off the laser, and it looks a little gummy, but we can just hit it with a little LA Awesome. And first we'll try just a paper towel to wipe it down. So there, it's shined right up. If I can get to focus on that real quick. Nice and shiny. Maybe a touch hot because there is just a slight curl to this card now. So I would imagine we could speed it up just a little bit or back the power down as well. But everything looks crisp. And once you kind of just wipe all that off there, it shines right up. All right, so went ahead and tried some stainless steel. They provided this little heart dog tag pendant thing, and ran just a small cat on there. Ran this at 350 millimeters a minute and 100% power, so really blasted it pretty hard. And I will try to put up a close-up of this. So, you know, whether it's interacting with the coating or whether it's actually etching into there, you know, it's hard to say, because there's definitely leaving a texture there, but that, you know, could just be the coating of the stainless steel. So, but it definitely did a pretty good job. Now, this little pendant took about 6 minutes, and that may have been a bit overkill on the power. It might have been able to bump up the speed a little bit just to get the solid marking, but went ahead and cleaned it up, used a magic eraser on it as well, and it seems to be on there pretty well. All right, so hopefully, as you saw there, we were able to cut through this black acrylic and engrave it, and it worked out pretty well. there is just a little bit of a rougher edge on the top edge of the cut, and I'll try to overlay some video that hopefully can show that a little bit better. So it's going to be a little bit of a balance. Now, I was running the engrave at 8,500 millimeters a minute and 25% power. And then the cut I was running at 250 millimeters a minute and 100% power with full air assist. And it seemed to get through just fine. Just had to poke it through the top, I think because of this, this little edge was kind of melting and then maybe just refusing in a couple spots. But overall, pretty good. I'd love to play around a little bit more and see if I can just get a little more of a polished edge on there. I went ahead and tried some slate tile and did two things. First off, I did this engraving of kind of this group of cats as a selfie. Obviously, this is kind of an AI image that was created. Now, it's a little blown out on the higher end, so needed to probably play around a little bit more with the contrast and the power settings, but the detail is there. You can see the whiskers and the eyes and a lot of the different colorations in most of the cats. And this was done at 10,000 millimeters a minute and 65% power as maximum in Jarvis mode, and I believe it was 300 DPI. So not too bad for that. And then of course did a vector engrave of my logo on the back. Went ahead and did this again, 10,000 millimeters a minute at 65% power. And that only took about 3.5 minutes to do one that's about 1.5 inches, 1.75 inches square. So, all right, now I know someone is going to ask, so we're gonna go ahead and try to cut some thicker material. I have a piece of clear aspen here, and it is 1/2 inch thick. I've had relative decent success with these in the past with the 20 watt diode ranges. So we're going to set this up, and one of the tricks to doing this is instead of focusing right on the top of the material, you want to try to get your focus point down to about the middle, and that's going to give you the most efficient and effective cut through material like this. So we're going to set this up, and then we will try to cut a circle through there and see if it comes out. And I'm guessing we're going to have to run a couple of passes, 2 to 3 passes maybe, and I don't want to run it too slow to add extra charring. In this case is where running a little bit faster with air assist on is going to hopefully help us. So I'm going to drop this in the laser, we'll give it a shot and see how it works. All right, so we ran the tests and it actually went pretty well. My first one, I had 3 passes at 200 millimeters a minute, 100% power, and it definitely cut out, but there was some overburning there. So I bumped it up to 250 millimeters a minute, 2 passes, 100% power, and had just a couple little fibers holding it in. And so then the last one, I took it down to 225 millimeters a minute, 100% power, full air, and it came out really clean. You see both sides are looking very good. Just a little bit of flashback from the honeycomb, and then the part itself isn't overly charred. Nice caramelization, fairly clean top and bottom. So definitely 1/2 inch material. And something lighter than this, like I said, this is clear aspen. It's a fairly soft wood, very clean wood as far as there's not a lot of varying grain in it. Definitely doable. Now, results are going to vary as you get into harder woods or with differing grains and such. So you're still going to have to do some tests, and it's not going to work for all woods, but definitely possible on some of these others. All right, so we've run a number of tests on this laser, and while I know that the room filled up with smoke and I had to put it in the enclosure to help contain that, I want to take a look at this filter and see how it looks after using this for a few hours on various materials and see if it's collected anything. So let's go ahead and do that. pop this out, and you can kind of see that's a little bit grayer, but on this side you can definitely see where this kind of fan box is. The rest of it is definitely getting darker, and so it is collecting some debris, but the reality is this small size filter and the openness of this is just going to still let a lot of smoke through. So if you were in an enclosed space such as my shop here, you're still going to want to do more to contain the smoke, be able to capture that through an air purifier or be able to vent it outside. So unfortunately, while I think it's a nice idea, this is just not enough to be able to capture it all and be able to run this safely in an enclosed space. So this is where I think I'm going to leave this review video. We've done a lot of my typical tests with the laser, and let me just kind of summarize it up. There's a couple areas that I felt maybe didn't quite live up to what I would like to see. That was that air filter assembly. It's a great idea. I think they were trying to do something different, and I applaud them for thinking outside the box, but in reality and application, it just wasn't capturing enough the smoke for my comfort, and so I did end up needing to put it into an enclosure. But that's really true of any of these open frame diode lasers. If you're running them out in the open and you have clear air moving through, then you can probably get by without it. But if you're running it inside and in an enclosed space, you're really going to need to be able to capture those smoke and fume vapors and be able to either contain them within an air purifier or in vent in the outside. The other item that was concerning was the air assist routing. It has that tight bend around the module, and I just, I had to kind of play around with it. It was working okay. We got air moving through there, but I think it could have been just a little bit better without that tight bend at the end. However, there are a lot of features I did like about this laser. For a 20-watt laser, it was cutting fairly well. I think it was in the upper end of the cut speeds and quality that I've seen in most 20-watt lasers. I also really appreciate having a variable air control on the air pump. Not all lasers come with variable air pumps. They have an on-off switch, and so you got all the air or none. I like being able to kind of play around with the air control, get a little bit going sometimes on certain engravings just to keep some positive airflow through that cone and keep smoke and debris away from that lens. And in other cases, I really want to crank it up when cutting, really blast that smoke and debris out of the way while we're trying to get at the material really well. So also another feature, I didn't mention this earlier, but I really appreciate that the fans turn off after a little bit from each operation. So they're not sitting there howling the whole time. If you're like me, you'll run a job and you might need to make some adjustments to a file. You might be swapping out some text or whatnot, and having that fan just howling the whole time can kind of get irritating. So this one runs long enough to try to capture enough of the smoke, make sure the components are cooled down, and then it goes down to idle, which I really love. It's a small thing, it's a creature comfort, but it really does make a big difference when you're spending a lot of your day working with the laser. Overall, this is really a pretty good value. At the time of this video, this is the kit that I was sent. It was $600, and that gets you the 20-watt laser, it gets you the air pump, it gets you the honeycomb bed, it gets you the rotary. It's really almost everything you need to get going with a diode laser. The only things I would recommend you add to that is some sort of enclosure. I'd recommend you purchase Lightburn to be able to control this, and neither one of those is going to set you back too much. You should be able to get an enclosure, even just one of the fabric tent ones like I was using, for $60 to $100, and then Lightburn is $60 for your first purchase, and then it's good as long as you want to use it. So really, you're talking under $800, a 20-watt laser with rotary, all the things you'll need to get going. So once again, I want to thank you for watching this video. I hope you found it informational, and if you have any questions about this or anything else that you've seen in my workshop, go ahead and leave me a comment down below, and if I've earned it, hit that like button. And if you want to see what I do in the future with reviews, with project videos, and with tutorials, go ahead and hit that subscribe button. I do try to get content out fairly regularly, and I try to mix it up to keep it interesting and informative. I will, of course, have links down below to this laser and other things seen in this video, so those will likely be affiliate links, and those do generally give a kickback to me as a small commission, but that's no extra cost to you, and as always, no pressure. Thank you once again for stopping by, and I hope to see you again, but in the meantime, I hope you can get out into your workshop and make something too. We'll catch you next time.